something we've kind of danced around but haven't specifically addressed yet is we've talked about radical form. Anytime we have the square root, cube root, fourth root, all those radicals are really rational exponents. Remember, rational are fraction exponents. Radicals are fraction exponents. Let's go back to when we looked at cube root of x to the 30th. Remember what we got was x to the 10th, because x to the 10th to the third power, I multiply my exponents, that gave me x to the 30th. But remember what we said was really divide by the 3. Well, that divide by 3 came from divide by the index. 30 over 3 is what gave me that 10. But remember the other problem prior, x to the 22nd, we said x to the 11th, because that's the number that's squared. When I multiplied the exponents, gave me the 22. But remember where that 2 came from. When I say up here cube root, I'm saying that because it's what number cubed gives me the radicand. Down here, when I say square root, I'm looking for what number squared. Well, in this case, that missing number, square, is the opposite of a square root. Sometimes that missing number is a 0, sometimes it's a 1, sometimes it was a 10 when we looked at the logarithms. What I'm really doing is dividing by that 2. What I'm really doing is dividing the exponent by the index. Hence, when I have the nth root of a to the n power, what I would say is, keeping that same base, I divide my exponent divided by my index. This is how we convert back and forth between radical and rational exponent form. And it works both ways. We can just bounce back and forth, swinging that index around as the denominator, or the denominator right back around as the index. Let's look at some examples.